Sir, in Euclid's division lemma, the term lemma sounds differently. I never heard about it. Lemma is the typical word to hear and pronounce, but it is just a result. It is used in proving the other theorems. Suppose one wants to compute the HCF of two numbers. The most common method used is factorization. But to compute the factorization of large numbers such as 65,842, 24,895 and so on is very difficult and takes a lot of time. So Euclid has came up with a theorem that would help us to find the factorization method easily in less time. This theorem is very simple and is just another form of divisibility rule, which we have studied in our lower classes. Sir, could you please explain us the theorem of Euclid's? Okay, listen to the theorem statement. Now, let us know theorem on Euclid's division lemma. Statement: if a and b are two positive integers, then there exists unique whole number q and r, such that a is equal to bq plus r, where 0 less than or equal to r is less than b. Do you remember the divisibility theorem? Dividend is equal to divisor into quotient plus remainder. The Euclid's division theorem is originated from this. Sir, but how is it possible to use this theorem to find HCF? Can you please explain us more clearly in simpler way by taking few examples? To understand more clearly, first let me explain the theorem by an algorithm, step-by-step manner and flowchart. Algorithm. An algorithm is a step-by-step procedure or formula for solving a problem. The word algorithm has come from the name of the Persian mathematician Al-Khwarizmi, earlier transliterated as algorithm or algorithm. The word algebra is also derived from a book which he has written called Hisab al-Jabr wal-Muqabala. Euclid's division algorithm is used to compute the highest common factor, HCF, of two given positive integers. To obtain the HCF of two positive numbers, say a and b, follow these steps. Step 1. Apply Euclid's division lemma to a and b, so there exists whole numbers p and r such that a is equal to bp plus r, where 0 less than or less than b. Step 2. If r equal to 0, b is the HCF of a and b. If r is not equal to 0, then apply division of lemma to b and r. Step 3. Continue the same process until the remainder is 0. The divisor that is obtained at this stage is the required HCF. Flowchart. Here let us know sequentially in the flowchart to keep the steps to find the HCF. Let the first number be a and second number be b. If a is greater than b, then according to Euclid's division, lemma a is equal to bq plus r, where q and r integers and 0 less than or equal to or less than b. Suppose a is equal to bq plus r. If r is equal to 0, then b is the HCF of positive numbers a and b. If a is equal to bq plus r, if r not equal to 0, we apply the division lemma to b and r and continue the process till the remainder becomes 0. If a is less than b, then according to Euclid's division, lemma b is equal to aq plus r, where q and r are integers and 0 less than or equal to r less than a. In b is equal to aq plus r. If r is equal to 0, then a is the HCF of positive numbers a and b. in b is equal to aq plus r. If r is not equal to 0, we apply the division lemma to a and r and continue the process till the remainder becomes 0. Now, let us do some examples by taking small numbers first and then large numbers.